HyperUA, a product of Projexsys Incorporated, provides RESTful Web connectivity to OPC-based industrial applications. In this video, I'm going to demonstrate a native app that Projexsys built for Windows 8. Using the app, we'll communicate with a HyperUA server using HyperUA's REST or hypermedia API. Through HyperUA, using only RESTful Web connectivity, this native app will communicate with a remote OPC-based application. This demo is a follow-on to our earlier video titled Native Apps, iOS, and there is a good deal of conceptual crossover between that video and this one. I highly recommend you review the earlier video, as it provides some contextual information which I won't entirely repeat in this one. Before jumping into a hands-on demonstration of our app, I should note up front a few of its characteristics and our goals for this demo. These points are quite similar to the ones raised in our iOS video, but where there are differences, I will point them out. This is a prototype app, not a finished product, and it does not feature a fancy user interface or graphics. Our goal, rather, is to demonstrate another concrete application of the REST and hypermedia concepts discussed in our other videos. Compared to our native app for iOS, this Windows 8 app has a more general focus. It functions as a kind of explorer or visualizer of OPC-UA address spaces, leveraging HyperUA's API. This app does not contain any OPC-UA software in its internals, and yet it's able to read all kinds of data from an OPC backend application. To keep it simple, our Windows 8 app is a read-only application. You may recall that our iOS app demonstrated both read and write capabilities. As mentioned previously, this is a native app and not a web browser in the usual sense. That being said, we used Microsoft's Win.js runtime for Windows 8 to build this app, so it's effectively built on top of a sandboxed Internet Explorer and employs native browser technologies, like the DOM, a native CSS selectors API, and JavaScript, to get the job done. Our iOS app, in contrast, was built with the Lua scripting language and involved a significantly different implementation. However, both native apps employ the very same underlying RESTful Web concepts and techniques for working with HyperUA's API, even while their codebases differ significantly. Like our native app for iOS, our Windows 8 app programmatically consumes HyperUA's API, that is, its hypermedia representations. The app follows web links, but not in a human-driven way as seen in some of our other demo videos. If you haven't already, I invite you to review our video titled Hypermedia for Industrial Apps, which you can find in the Projexsys YouTube channel. It provides a bit more background on the concepts involved in a hypermedia API. Alright, let's take a look at our Windows 8 app and HyperUA working together. By the way, this video was recorded in high definition, so you'll want to bump up your playback resolution using the YouTube controls if you haven't done so already. We have a familiar setup as seen in our other videos. A Wonderware InTouch demo is running on a Windows server in Dallas, Texas, with KepServer EX running alongside InTouch providing an OPC-UA front end. HyperUA is running in the foreground of a terminal session on a virtual Linux server in New York. I've already used HyperUA's API to establish a session with the KepServer running in Dallas. Now I'll pull up a Windows 8 virtual machine running on my Mac laptop in St. Louis. Scrolling to the right of the start screen, in the bottom right, there is a nondescript icon for our native application, which we've named HyperViz. Let's fire it up. The app was built using Visual Studio 2012, and as I mentioned previously, we used the native Win.js runtime. I'll open the settings flyout, as I need to provide the URL to our HyperUA server running in New York. And I'll point out some of the available options. The app basically acts as a web crawler, and will automatically navigate through a selected session resources address space. I'll bump up the maximum number of nodes to visualize to quantity 80, as I already know that's enough to pull in most of the InTouch-related variable nodes. The app visualizes nodes which match only the selected node class, a concept which comes directly from the OPC-UA specifications. The default is to track only variable nodes, and we'll stick with that for the moment. Likewise, the app will only crawl references which match the selected reference types. Again, that's a concept which comes from OPC-UA. The default selections are has component and organizes, and we'll go with those as well. Both node class and reference type information can be determined programmatically from the metadata contained in HyperUA's hypermedia representations, and that's precisely how our app implements its filters. Please review our Hypermedia for Industrial Apps video if you'd like to learn more about the concepts involved in a hypermedia API. After clicking Save, I'll pull up the app bar control and click the Scan command. A control quickly appears corresponding to the Kepware session on our HyperUA server. After clicking that, we're brought to a split view, and in a few seconds the app will hit its total scan count of 80. The list on the left corresponds to variable nodes in the Kep server's OPC-UA address space. I'll start to scroll toward the bottom of the list of nodes, and we'll soon begin to see the list of variable nodes specific to the InTouch demo. I'll select the reactor temperature node, and now on the right you can see the OPC-UA attributes list. What's happening, in a nutshell, is that the app is consuming HyperUA's hypermedia representations and generating native controls and readouts from the data contained in the HTML. To the right of the attributes list, we have a pair of app-specific controls. First, I'll activate Monitor. Notice that the value of the node will begin to continuously update in the textual displays on the left and in the attributes list on the right. Now I'll activate Chart. We get a basic charting mechanism that keeps track of a few minutes worth of data. We can monitor as many nodes as we'd like, of course. Now I'll activate the chart for the reactor level and product level nodes. That's basically it for the features of our app, but I also want to show you the same app running on real hardware. Now I'll pull up a live feed from a webcam pointed at my desk. Here you can see the same app running on a Windows Surface RT tablet. My camera is struggling a little with the high gloss of the screen and the contrasting colors. In person, the display looks as sharp as that of the virtual machine. You should, though, be able to make out the data graph on the bottom right. I changed the colors of the graph so they would show up a little better in the webcam's view. Otherwise, the tablet is running the same Windows 8 app. Here we're looking at the reactor temperature node, with the graph scaled out to show several minutes worth of data. Now I'll tap the control for the product level node. I already have the chart enabled. Flipping back to the virtual machine, note that we're now looking at the same node on both devices. Let's see what happens when we toggle the output valve in the InTouch HMI. Almost immediately, we can begin to see the falling product level reflected in the graphs on both the tablet and the virtual machine. I'm going to reach over and widen out the graph on the tablet so we can see several minutes of data for this product level node. I want to return to the virtual machine now and experiment with some different settings for our app. First, I'll change the node count to 50. Then, I'll select all the type-related node classes. And for good measure, I'll select all of the reference types. I'll click Save, and then I'll reinitiate the scan of the address space. Returning to the split view, we'll now see a completely different readout of nodes. So there you have it, a native Windows 8 app consuming HyperUA's API, allowing it to communicate with an OPC application while itself employing only RESTful Web techniques. That is, there's not any OPC-UA software per se inside our Windows 8 app. Instead, our native app is retrieving HTML representations from HyperUA, which correspond directly to OPC-UA sessions, nodes, and so on, per the Kep Server EX front-end to Wonderware InTouch. The beauty of the RESTful Web approach is that web technologies and web-driven applications are well suited to rapid and flexible development, allowing both native and browser-based apps to be quickly tailored and adjusted to meet the evolving needs of industrial applications. Thank you for watching. We invite you to learn more about HyperUA and our vision for the future, and how your company can become a Projexsys OEM. Please visit our website and feel free to shoot us an email with any questions you may have. You can also find us on Twitter and Facebook.